Okay, here's what you should have in your notes. Remember, the notes are things that you can then look at and refresh your memory anytime you do your project.
Okay. So, in looking at this current unit, I kind of thought, I talked to Ms. Cork about this, and about this kind of thought that you need to know some basics about the atom a little bit to understand some of these things. It's difficult to find a section in the NGSS where this stuff gets taught. Maybe it happens earlier in school than the NGSS. So, just want to talk about the basic structure of the atom for a minute because it's got there are a lot of important concepts in there that you need to know. So if you just Google atom, these are the images you get. Okay? You may have seen these, you should have seen images like this before, you may not have been 100% certain that they were about the atom. It's a kind of common image in science, especially starting around the 1940s or 50s. Really the 50s, this kind of image gets very popularized. In general, this is called the Bohr model of the atom. Here's the thing you need to know. Atoms do not look like this. So, funny thing about science, often we diagram stuff, and it gives you an idea of the general way the atom functions, but this is not what they look like. Okay? Totally fine to draw this and diagram it. Okay? If we click on any one of them, we see a few common things about them. Assuming this diagram is generally true about most atoms, what can you tell me about where the protons and neutrons are?
They're in the center of the atom.
In the center. And in general, where would you say the electrons are there?
Sort of circling around the protons
Okay.
and neutrons.
These are real fundamental things, and a lot of times it's really hard for people to remember them. So, I'll tell you a quick story. When I was your age, my mother was a 4th grade teacher. And so, you know, elementary teachers teach all the subjects, right? My mom had a unit on atoms. She wasn't super strong in atoms, which is a little funny because my dad's a physicist, was a physicist before he became a minister. And my brother's a physicist too, actually. And that's kind of what they study. But that's a large portion of what they study. Atoms are done a lot. So, she wasn't totally certain about it, but I have got a lot of science fiction and I knew some things about it, so she asked me to come teach her students about atoms. Well, I had seen a really great thing on a TV show called WKRP in Cincinnati. I bet Ms. Cork remembers that show. She's the only person in this room. WKRP in Cincinnati.
I love it. Oh, so you're going to show the video of
Venus flytrap.
Oh.
See, she knows. So I told this story because I thought it was a really good way to remember atoms. Well, when I was your age, barely anybody had a computer, okay? When I was your age, it was 1988 or 89.
So like 30 years ago?
Almost. 25. Yeah, I'm old, dude. I'm turning 40 this Saturday.
So you're like,
Midlife crisis.
So, back then, you couldn't just, you know, if I hadn't happened to videotape, I don't even know if we had a VCR then, if I hadn't happened to videotape that episode of WKRP, there's just no way to see it again, okay? When I started teaching this, I thought, I wonder if I can find that online. And sure enough, go to YouTube and found Venus Flytrap, who's one of the DJs at this radio station. And let me give you some setup, okay? Look. Why did you go over there? So here's some quick setup. The guy on the right is Venus Flytrap. It's not his real name, it's his radio DJ name. The WKRP is an AM rock radio station in Cincinnati. And this is the early 80s, late 70s, early 80s, when this show's on. At that time, cities like Cincinnati, Detroit, places like that, were experiencing a lot of what has now come to be called white flight, meaning that richer white people moved out of the urban core out to the suburbs, and poorer people that not always, but a lot of times were black, got left in the core of this city. Okay? And so this is Venus's nephew, and he's grown up kind of in this impoverished area of Cincinnati, and he's thinking about dropping out of school. Okay? And Venus is trying to keep him in school. Okay? So they make a little bet.
I can give you the basic of the atom in 2 minutes. You'll understand it perfectly and remember it for months.
2 minutes? You crazy, you know that?
If I can teach you about the atom in 2 minutes, will you go back to school and finish out the year? How about it, huh? Come on, you're a betting man. How about it, Arnold?
Yeah. Yeah, okay, sure, you got it.
I got your word.
Yeah, you got my word. In 2 minutes.
We got a deal.
Yeah, we got a deal.
All right, sit down.
Okay.
There are 3 gangs on the street, right?
Yeah, 3 gangs.
And this right here is the territory. Now, here is the neighborhood. Got that?
Yeah.
And right in the middle of this neighborhood is a gang called the New Boys.
Yeah, the New Boys. Good name.
Okay. Out here on the outside of the neighborhood, on the edge of the neighborhood, is another gang. You know, these are real negative dudes, really negative, right?
Right.
Now, they call themselves the elected ones.
All right, be that.
You got that? Really negative. They don't like nothing.
Right.
And they all the time out here circling around the neighborhood, just circling, you know, checking out the New Boys. Now, the New Boys see this, and they get, they figure there's something wrong here, so they make a deal with another gang, a gang of very happy-go-lucky guys. They call themselves the Pros. The Pros. Now, the Pros are very positive cats. See, they got all the good-looking women, right?
Yeah.
Right. See, now the Pros and the elected ones, interesting thing, they hate each other. So much so they keep the same number of members in the gang, just in case you did.
Right.
So if I got 10 elected ones, how many Pros do I have?
10.
All right. Now how many gangs do I have?
3.
Name them.
The New Boys, the elected ones, and the Pro.
All right. Who's here?
The elected ones?
All right. Now what are they, negative?
Yeah, negative.
All right. Now who's positive?
The Pros, and you running out of time.
All right. Now you see right here, the Pros and the New Boys, they call their hangout the nucleus. Yeah. Now see, that's a real tough word. It's Latin. I kind of think it's Swahili, and it means center.
Yeah? What is it?
It's nucleus. Say it.
Nucleus. Is that really African?
Say it.
Nucleus.
You got it?
Yeah.
All right. Give me another Swahili word. It's tron. It means dude.
Yeah, Tron. Dude.
All these gangs like that name so well that they all decide to use it. For instance, the Pros right here in the middle start calling themselves protons, and the New Boys, well, they start calling themselves neutrons. And out here on the edge here, the elected ones, they start calling themselves the elected.
The electrons, the protons, and the neutrons.
Yeah. And all this right here, this is the neighborhood. This is block after block of nothing. You understand block after block of nothing, don't you?
Yeah, I know all about that. And your time is up, Professor BJ.
Good. I was finished anyway. Now you go on back to school.
School? Man, all I know about is a bunch of damn gangs that live in a round neighborhood.
Arnold, that's the atom. That's it, man. That's it. What's this right here? Huh?
Protons and neutrons.
All right, they call this the what?
Nucleus.
All right, what are these guys up here?
Electrons.
Are they negative or positive?
Negative.
And how do they move?
Round and round.
And if I got 2 of them, how many protons do I have?
2.
Now, protons negative or positive?
Positive.
All right, and what's all this right here?
Oh, that's the neighborhood.
Which is?
Nothing.
You got it, man. You can name it.
you can remember everything you really need to remember about the atom. Okay? If you want to watch that again, if you go to YouTube and look up WKRP Venus atom, that was what I searched for. Actually, just Google search that. You will find that clip. Okay?
Or if you use Moodle, like you're supposed to, you will see added to Unit 2 tonight. It'll be called Video Chester Lecture on the Atom.
So,
Real fast, let me just check and see. Hector, did I miss you? Caitlin. Fabian. Logan. Chris. Laura. Jesus.
Here.
Oh, he's here. That's why I just checked this. And Madison. All right.
okay. So, what's the middle part called? Actually, let me pull one up that's not labeled.
Nucleus.
Makes it really easy. Middle part's called nucleus. Two different kinds of particles in there. Called the what? Protons and neutrons. What's out here? And how do they move? Round and round. What's in between here and here? Nothing. Hey, you got it. Smart. Now, this should blow your mind, okay? Because you're made out of atoms. Essentially all matter in the universe is made out of atoms. Well, depends how you look at it.
Now, you say essentially, so what is it?
Well, so in stars which contain most of the matter in the universe, the electrons are actually stripped off and somewhere else, and the nuclei are by themselves, okay? So everything's made of protons, neutrons, and electrons, but the largest everything on Earth that you're familiar with really pretty much is made of atoms, okay? Lightning bolts get hot enough to turn matter into plasma, which is this state where the electrons are separated, okay? But
It's like, what about like a plasma TV? Like, does that do the same thing
No.
for lightning? Or just go
it's
plasma?
just called plasma. I say no. There's electricity in there, so I don't know enough about plasma treated TVs to actually give you a really good answer on that. They don't operate at that temperature though, I can tell you that. When you think of matter, you should think of it being composed of these things. Okay? So you're made out of these things. Your Chromebook's made out of these things. Your chairs, your table, the air molecules are made out of these things. Okay? You are made out of mostly air molecules. You probably didn't know that. Okay? You're made out of the components that are found in the air. Okay? You remember our solar system model we did outside? If the sun were the nucleus, then the closest electron to the nucleus would be out where Neptune was. Yeah, what? And everything in between is what? Nothing. Not air, okay? Not like what's in this room. There's lots of stuff. This air, there's a lot of stuff in this room. There are a lot of atoms of air in this room, a ridiculous number. A number so big that it's basically impossible for you to imagine, or me to imagine.
So it's just a vacuum then, in between?
Yes, there is absolute nothing empty space in between.
So,
Okay?
what occurs
So
in that
a
space?
vast majority of all objects are empty space. I mean, when I say a vast majority, I mean 99.99999999999999999% of them.
So what's
is
that 0.1?
that stuff.
Oh.
Protons, neutrons, and electrons. Now, what will really blow your lid is this. Yes, Ethan? So there's some weirdness about electrons in quantum mechanics that let's not get into right this second, but yes, there's one argument that there might only be one electron in the universe and it's everywhere simultaneously. I don't know how seriously physicists take that at this point, but somebody was taking it seriously at one point. So there's some weirdness about electrons. The protons and neutrons are way more massive than the electrons, like so much more so that we don't even count the electrons when we think about how much an atom weighs or how much mass it has. Okay? These are the really solid parts of the atom. Here's the freaky part. They're not solid either. If you look inside these, they're actually made up of even tinier particles called quarks, which are spinning around and taking up space. So even the solid parts are filled mostly with nothing, which is freaky. Which means that
We're on nothing.
how is it possible? Why can't I just pass, you know, there's barely anything anywhere. Why can't I just slide my hand right through this, Miguel?
Because the electrons on both, correct me if I'm wrong, the electrons, like, their fields collide. And it
Okay,
gives us
the electrons have what charge from the video? Negative. Electrons are always found where in the atom? The outside. What do like charges do with each other?
Repel.
Repel. So when you go to touch this table, what really happens is, if you got really close, you would see the electrons don't actually get that close to each other given how small they are. They have this really strong force. It's called the electromagnetic force. And they go like, whoa, I'm not going to get near you, dude.
You can't actually touch.
Can't push the electrons together. You don't have enough strength to do it.
So I cannot hold a banana,
You can totally hold the banana.
Whoa.
but I cannot touch a banana.
Well, insofar as the common word touch means touch, sure you can. But no, your electrons are never bumping up against the banana's electrons. No, there's always a gap.
So what about when you cut into the surface
You are
of an
shoving the atoms apart using the field force of the electrons on the outermost atom atomic layers of the knife.
So are atoms always being created, or are they just...
Nope. Great question. All atoms in the universe, as far as we understand, were created at the beginning of the universe, at the Big Bang, which has an interesting implication. Anybody know how old the universe is? I taught you this.
8 billion?
Earth is 4.5 billion years old. The universe is about 13.6 billion years old. Which means that every atom in the universe is 13.6 billion years old.
Meaning
Which
that
means
we're
that you are made out of 13.6 billion year old parts. So the next time you get carded, and they're like, you're under 21, you can be like, oh wait, dude, I'm 13.6 billion years old.
So, I have a question.
You have a lot of questions, which is great.
Well, this one's kind of like,
I think we finally found a subject Miguel's interested in, or he had coffee this morning or something.
well, whenever species reproduce,
Okay?
does it create more?
Nope.
So,
You are made up of atoms that were parts of other living things. What place you get your atoms? What kind of cereal were you just eating, Hunter? Okay. Some kind of Cinnamon Toast Crunch? Most of that cereal is made out of wheat. Wheat comes from a plant. The wheat, the part that you eat is actually the seed of the wheat. Interesting side note, that seed is a baby wheat plant. Okay, there's a little tiny embryo baby wheat plant, and then most of the seed is food for that plant. And what you do, you pull the baby wheat plant and you crush it into powder, and then make cinnamon toast out of it, cinnamon toast crunch, and then Hunter's like, I'm eating your wheat babies. Okay, so biology is brutal, folks.
Put together in that order.
So, yeah, but that's what's happening. Here's the thing, the wheat, remember I said you're made out of mostly air? The wheat plant is pulling carbon dioxide and water out of the air, okay? It's pulling CO2 directly out of the air, but rain is falling onto the ground and it's sucking up the water, okay? And it's building itself out of carbon dioxide and water. When you eat that baby wheat plant and all its brothers and sisters, okay, your body takes apart all the molecules and it takes them to the cells, and then your cells take those atoms and molecules and build more you out of them. So you're literally are what you eat.
So we're like
You are
recycled.
Yes.
Yep.
And your atoms have been used by dinosaurs, by other people. There's a very high probability that you have some of Einstein's atoms.
So
in you.
is this where Einstein's theory of relativity comes in?
No, it has nothing to do with that. It doesn't have to do with relatives. It has to do with some other thing. So, yes.
Isn't there like this statistic like that like every year the same rate of people being born and dying is the same?
No, we actually know whether or not that's true. It's called birth rate and death rate. It falls generally under a study called demographics. And in fact, more people are being born than dying, and that's why the population is going up.
Oh, I thought there was like the same rate.
No.
Okay, let's pause for a second to get back on some notes. So I have shared with you, in case you couldn't find it, a template, and I already typed in a summary of Venus flytrap's description of the atom. So on the left is my key term, atom. The boxes, if you use the template, will expand as you type into them. So nucleus is in the middle. I need more information, so I put in parentheses. The protons that are positive and the neutrons that are neutral. That's what's inside the middle. They're surrounded by lots of empty space. Remember the empty neighborhood. Then on the outside are the electrons that travel round and round the middle. The negative dudes that go around the neighborhood. The number of protons and the electrons are equal, which makes the atom neutral. Because positive and the negatives, we haven't got into ions and protons. Now, that document, as it stands right there, has been shared with you. But let me show you the notes that I have added as Mr. Chester has been talking. You should not just be sitting here. You should take notes. There's actually research out there that shows that if you write things down, you will remember it like 80% better than if you just hear it. So he already talked about the atom's mass. And he told you that that's the protons and the neutrons. The electrons are not a part of the mass because they are so small. He talked about the light charges repel. That's why the electrons do not touch each other, since they're all negative and they push away, which means repel, against each other. You need to get into the habit is whenever teachers are giving lectures of taking some notes from it. So Mr. Chester.
The only things I would add is that all matter is made of atoms. And you can't easily put a drawing in yours, but you guys have ways to draw, right? I would add a drawing. You could even go grab a picture of an atom labeled and put it in. Okay? I would add a drawing so I had a reference.
Remember, you can
If
do
I
a
was
screenshot. So
sitting
you
in
can
college
add
with my notebook, because back then we didn't all have computers, I would have just hand drawn what I saw on the board. And she's totally right. You will, almost everybody always remembers a lot better when they're actually actively writing stuff down. I have not seen a statistic on the difference between typing it or handwriting it.
Yeah,
See the difference?
there is, it's an informal study, but there is one that's out there that says handwriting
It's better?
is better.
Wouldn't surprise me.
But they have gotten the study, I forget which university that I mentioned last week, where they compared students that took no notes and heard a lecture, a week later took a test, compared to students who heard the lecture and took notes, and about 80% who took notes made A's and B's, and about 80% who took no notes failed the same test.
Right. So taking
Pretty
notes.
much the difference between an A and a B and failing. You need to get into the habit of taking notes.
And by the way, you can take notes even when you're not, even when you're doing research on your own.
Yes.
Okay.
right.
Thank
And
you.
so
Helpful.
the original stop part you already have. It's a shared document. The rest is what I have added. You should keep adding as Mr. Chester keeps lecturing about the content.
Okay, so let's take that to get back to where we started. We could go on about what you're made out of and stuff forever because it's infinitely interesting, to me at least. One last quick note though. The Earth, when we go to that number, hey, the universe is 13.6 billion years old, but the Earth is only 4.6 billion years old, then you have to, there's a natural question, which is, well, so how is the Earth not as old as the universe? Well, the atoms that make up the Earth are. But this particular collection of atoms, just like your particular collection of atoms, the reason the carding thing doesn't work, the reason, first of all, the guy at the liquor store is not going to believe you're 13.6 billion years old, and he doesn't know anything about atoms probably. Maybe he does, but your particular collection of atoms is only 14 years old or whatever, right? You're all made out of spare parts, and the spare parts have been used over and over. And the really awesome part is, we watch this happen in the universe. Stars, giant stars, much bigger than our sun, occasionally explode. Okay? And when they explode, they create all the elements that are in the universe, iron and all this stuff. Actually, iron can be created in a star, but anything heavier than iron is created in an explosion of a star, a supernova. And all that stuff gets scattered. Well, one of the forces that you know about, called gravity, will slowly pull that stuff back together, and when enough gets together, it becomes a new star. That's where our sun came from. And the rest of the stuff, there's not enough to create a star, creates planets. Okay? Well, that's all made of atoms. And what were those atoms a part of originally in this story started? A giant star.
So what about
Which means your atoms that you're made out of
or stardust?
are literally stardust. We are all literally made out of stars. Probably the same star. Yes?
So what about like black holes?
Let's go into those at a different time. But they're just such a large collection of mass that even light can't escape it.
So if it's not escaped, like is it absorbed or
No,
is
it's
it?
just stuck in orbit, kind of. We
So-
can talk about that later.
Okay, well, one more question. Can atoms be destroyed?
Nope. But they can be split. Yeah.
Like when
But if they're
cut?
split, they regenerate, right?
No, they're
They're
like
split?
starfish. When they split, they split. We can talk about that later. Let's hold off. Yes, Ethan. Neutron. I don't know enough about neutron stars. I mean, white dwarfs are just so dense that. What happens in a star is this. You know how I said you don't have enough force to push those together? Right? With enough gravity, which is the most powerful of the four basic forces, gravity can push these together so hard that the electrons are like, yo, I'm out of here. Okay? And then it actually smashes the nuclei together. Okay? And in this case, in our sun, most of those are hydrogen. Most stars are mostly hydrogen. And a hydrogen is one proton, 0 neutrons, and 1 electron. Okay? And it actually smashes those protons together, and when they hit, they release an incredible amount of energy. The amount of energy that it releases is summed up in this equation that you may have heard of, E equals mc squared, okay? Which means for a very small amount of mass, a ridiculous amount of energy is created, and one of those protons turns into a neutron, and now and 2 more of those get jammed together, and you have 2 protons and 2 neutrons, and that's an element called helium. The only difference between the elements, iron, helium, hydrogen, carbon, all that stuff, is how many protons, neutrons, and electrons they have, and really how many protons they have. We'll talk about that in a later unit, okay? But those things are smashed together so hard, they release all this energy. That's why the sun's not going to run out of energy anytime soon, okay? The sun is nuclear. It's a ridiculously huge nuclear weapon going on constantly. That's where the energy is coming from. Crazy, right? Yes?
Okay, so like take it to space, you got all the radiation, all the dust, all the
Okay, radiation isn't matter, but okay.
take away
take out everything, it does not weigh anything. But I guess you're talking about dark matter and dark energy. I don't know enough about dark matter and dark energy to give you any huge. Let's talk about this later, Ethan. I'll talk to you about dark matter and dark energy later. Okay, so what's the charge on? What's this called? Everybody, what's this called? What's its charge?
Negative.
One of these is a what?
Neutron.
And the other is a,
Neutron.
and protons charge is,
Positive.
and neutrons is, and the place they hang at is called the, and so these are opposite charges, right? So they actually should attract each other, but we're not going to go into atomic theory, but electrons have enough energy that they stay around the outside. And remember, they're really pretty far away. The reason two objects bump into each other is it's the field of these electrons. And you remember you had a bunch of stuff in your reading that you were supposed to do that said two things don't have to come in contact to create a field that affects each other, right? Well, now you know that nothing comes into contact. It's just the fields of those things coming into contact. Crazy, right?
So what are fields made out of?
What?
What are fields made out of?
They're made out of a force, okay?
Then how do you feel like texture is?
Because you're feeling the force of those electrons. You know when you take two magnets, North Pole to North Pole, and push them together and you feel them resist each other?
Yeah.
It's like that, only a lot stronger. It is actually the same force, only it gets infinitely stronger the closer you get, not infinitely, but it gets exponentially stronger the closer you get them together, okay? So far that you can't actually end up closing the last little tiny bit of space, okay? So you're feeling a field. That's what you're feeling. So this is why fields and forces are intertwined, okay? Okay. So we know the basic parts of the atom, and we know that these electrons are responsible for generating a field which affects each other. When you line up enough electrons in the right way, and this happens naturally in some materials, okay? The field that they generate becomes much larger. Any idea what kind of object I'm talking about right now?
Wait, say that again?
When atoms are arranged in the right way, and some natural materials have this property, the field that they generate becomes much larger than normal. Iron, nickel, and cobalt are materials that respond to this.
Like conductors or?
Starts with an